Hello everyone. So today I am going to start the past paper of A level physics, and this is my first tutorial. Okay, so this is my first tutorial, and after if you didn't subscribe my channel, so kindly subscribe my channel because it motivates me to do more. And this is my first tutorial, so hopefully you will also enjoy my all lectures. So let's start from the first MCQs. So the first MCQs is this is the chapter 1, okay, A level chapter 1. Diagram show a cathode ray oscilloscope trace of a sound wave. The time base is calibrated at 2 millisecond per centimeter. So as you know that we have, let's say this is my oscilloscope. Okay, so in oscilloscope we have a small window and small screen. You can say that that is the small screen, and small screen is given to you that the graph shown on the oscilloscope is this one. Okay, so here we have lots of button. So there is a time base button. Let's say this is my time base, and time base is put on this digit. What is this digit? That is 2.0 millisecond per centimeter. So the question is, what is the frequency of the sound wave? So frequency, for frequency I need time period. So time period, let's go toward the time period. So time period is, this is my time period. Time period is the complete revolution of the signal. So from here to here, this signal complete one revolution. Okay, so that is your time period. Okay, now count the boxes. So this is 1, 2, 3 and 4. So one time period cover how many boxes? One time period cover 1, 2, 3, 4, 4 boxes. Okay, so this one box is 1 centimeter. So time is given to time, you can find it like this, that time is equal to 2.0 millisecond per centimeter. So if you multiply this 4 boxes, one box is 1 centimeter, so 4 box will be equal to 4 centimeter. So if you multiply here 4, like time will be equal to 2.0 millisecond divided by centimeter, and if you multiply by 4 over here, so this centimeter will cut out by this centimeter, and 4 times 2 is equal to 8.0 milliseconds. So this is my time period. Okay, 8.0 millisecond is my time period, and we know that the frequency is the inverse relation of the time period, and that is equal to 1 by 8 milliseconds. So 1 divided by 8, 1 divided by 8, if you calculate it through calculator, so let's try it. 1 divided by 8, that's equal to 0.125. So 0.125, that's equal to 0.125 divided by millisecond. So 10 to the power minus 3, when it come over here in the numerator, so it will become kilo. So kilo, and the unit of frequency is hertz, so kilohertz. Okay, so your frequency is 0.125. So is there any 0.105? No, but unit is hertz, so 0.125 kilohertz, so it will be 125 hertz. Yeah, that is present in the option, so this is my correct option. Now let's move toward the another MCQs, and the another MCQs is Let's zoom out a little bit. So another MCQs is the diagram show a square wave trace on the screen of the cathode rays oscilloscope. So what is cathode rays oscilloscope? I discussed it a little bit in first MCQs. A grid of 1 centimeter squares cover the screen. The time base setting is 10 millisecond per second. So what is the approximate frequency? Okay, not the exact frequency, but the approximate frequency of the square wave. So let's find the time period first. Okay, okay, a grid of 1 centimeter. So one box is 1 centimeter square. So it will be like the one box. So this time period is started from here, then it move on here, here, here. Then again the same time period is started from this point, and it will repeat itself. Oh, okay, so up from here to here we have one time period. Okay, so one complete box is equal to 1 centimeter square. So what about this is one. Let's say split this box in three. So 1, 2, and 3. So this this will be this is 1 centimeter, 1 centimeter, and this is 2 by 3. This is 1, 2. So 2 out of 3, 2 out of 3, 2 out of 3 portion. So this portion is 2 out of 3. It means one time period is equal to 2 out of 3. So one time period is equal to 2 out of 3. Okay, 2 out of 3 centimeter. Okay, now time scale is 10 millisecond per centimeter. So it will be 10 millisecond per centimeter. So it will be 10 millisecond per centimeter, and that is the we need to find the time. Okay, so this is one time period cover this much length. So if I multiply over here 2 divided by 3 centimeter, so this centimeter will cut out by this centimeter, and 2 times 10 is 20 millisecond. 20 millisecond divided by 3, so it will be 20 divided by 3. So let's do it through calculator. So it will be 20 divided by 3, and that's equal to 6.66 millisecond. So that's equal to 6.66 millisecond. That's equal to one time period. Okay, so frequency, and the frequency will be equal to, frequency is the inverse of time period, and that's will be equal to 1 divided by 6.66 milliseconds. So that's equal to 1 divided by, that's equal to 0.15. That's equal to 0.15 kilohertz. 0.15 kilohertz or 150 hertz. So now let's move toward the option. Is there any 150 hertz or near to 150 hertz? Because they said approximate frequency. So there is 70 hertz, which is too far away from the 150 hertz. There is 150 hertz, 140 hertz, and there is another 280 hertz, 1400 hertz. So we have this option is near to this 150 hertz. So this will be the correct option. Okay, now let's move toward the another MCQs. Okay, so the third MCQs is the diagram based on a cathode rays oscilloscope is set at 6 milliseconds per centimeter. A trace consisting of two pulses is recorded as shown in the diagram. What is the time period between the two pulses? So we need to find the time period, time interval between two pulses. So this is one pulse and this is second pulse. Okay. Okay. So this is my curve. Okay. So it will repeat after this. Okay. So this is my length. So that is 4.5 centimeter. Okay. So time based scale is time based is equal to 6 millisecond per centimeter. So your time interval that's will be equal to times 4.5. So let's multiply this 4.5 times 6. 4.5 times 6 is equal to 27. So 1 is 27 millisecond. So is there any 27? No, no. Yes, there is. So this is my correct option. 27 millisecond is the correct answer. Next MCQs is a micro screw gauge. This is related to micro screw gauge, and the MCQs is a micro screw gauge is used to measure the diameter of the copper wire. Okay, right? The reading with the wire is position is shown in diagram 1. The wire is removed and the jaws of the micrometer are closed. The new reading is shown in diagram 2. Okay, new reading. This is first and this is second reading. So what is the diameter of the wire? No. Okay, so what is the diameter of the wire? So there is also some sort of zero error. Zero error. There is some sort of zero. So let's find first the zero error, either that is positive or negative. So I am going to zoom it a bit so that you clearly see the diagram. That's also not too much clearer, but it's okay. So there is a zero error, and we know that in the screw gauge, if this scale is on the right side of the zero, so that is known as positive error. If this is on the left side of the zero, so that is known as negative error. So now in this case we have positive error. So how much positive error? That is 10 and that is 15. So 10, this will be 11, 12, 13. No. This will be, this is 10, this will be 11, 12, 13, 14, and this is 15. So this is a point, this is 14. So 14, so this is in millimeter, so it will be 0.14 millimeter error, and that is the positive error. So this much error is present. It means this positive error, it means that we will subtract it. We will subtract it from the final answer. So we will subtract it from final. So let's start. So this is 1, 0, this is 1, this is 2. And this is a 0.5, 1.5, 2, 2.5, and 2.5. So 2.5 plus something. As you see, there is a small distance. So plus something. What is that something? So we will find that from this scale. So that something is, this is 5, this is 10. So that something is this is 9, I think 9. This is 10 and this is 9. So it will be 0.09. So 0.09 plus 0.09. So it will be 2.59. So this is my final reading. And we already have positive error. So we'll subtract this minus 0.14 millimeter. So it will be equal to 2.45 millimeter is the final and correct answer. So is there any 2.45? Yes, 2.45. So this is the correct option. Okay, next, the following trace is the following trace is seen on the screen of a cathode-ray oscilloscope. Okay, that is okay. The setting of the time base is then changed from 10 milliseconds to 20 milliseconds, and the Y sensitivity is unaltered. Which trace is now seen on the screen? Okay, so this is 10 millisecond. Okay, 10 millisecond per centimeter. Okay, and this is 20 millisecond per centimeter. Okay, so we switch from 10 millisecond per second to 20 millisecond per second. So this is 1, 2, 3, 4 boxes, and time period is for 10 millisecond. Time period is TP means time period, that is 10 millisecond times divided by centimeter, and how many boxes? That is 1, 2, 3, 4 boxes. So that's equal to time period is 40 millisecond. Okay, time period is 40 millisecond. Now time period is 40 millisecond. Now if I change it to this, so that will be equal to for 20 milliseconds. So that will be time period 2. This is 1. So that's equal to 20 times 4, 80 milliseconds. So this will be double of this. Okay, so it will expand. So is there any expand curve in the options? This will be any other. This is not possible. This is also not possible. This is also not possible because the magnitude is higher, and I think this is the correct option. High magnitude is after 2 boxes. So high magnitude should be equal to after 2 boxes. So this is not possible. 2 boxes, but this is it's compressed. This is a 2 boxes, but it expanded, and yeah, this is the correct option. 80 milliseconds. This is also not possible because the magnitude is high. So inshallah in next video I will discuss the other MCQs. Thanks for watching. Allah Hafiz.